Okay, so let's talk about volumes now. Um, if we take a look at this top picture is showing us how we're going to form our disks. And so you can see that if we were to take a rectangle and rotate it around an axis of revolution, then that rectangle, as it sweeps around, it's going to sweep out the shape of a disk. And that's what creates a disk for our pictures. Now, if we look at the bottom picture now, we're going to take this blue region right here. And if we were to rotate it about the x-axis, it's going to create this blue solid that's right here. And what we can do is we can approximate the volume of the solid by, in this case, using disks. So one disk, again, is formed by a rectangle. In this case, here's our representative rectangle drawn perpendicular to the axis of rotation. And as it sweeps around, it's going to sweep out this one disk. And if you imagine that there were several disks or several rectangles that were drawn here, and then as they all rotate around the axis of rotation, it's going to create all of these disks right here. And these disks stacked on top of each other, or side by side in this case, I guess, they approximate the volume of this blue figure. And so the idea is that the more and more disks we can fit in, the smaller and smaller the disks are going to get, and the better and better our approximation is until we can fit infinitely thin disks. And that's finding volumes by disks. We'll get into the actual calculus part, but right now just try to imagine the picture. Now here we have the same thing going on with washers, but this time the difference is our representative rectangle does not touch the axis of rotation. So as it sweeps around, there's going to be a hole formed. And so here's that representative rectangle. Here's our axis of rotation. As it sweeps around, we have the hole on the inside and we have the outer radius on the outside, and that's creating a washer, a disk with a hole. So that's going to be formed. Sorry. If you take a look at the picture on the bottom, we've got this blue region that, again, we're going to rotate about the x-axis, and you can see the blue region doesn't touch the axis of rotation, except maybe at some points, but it doesn't always touch it. When you draw a representative rectangle, it doesn't. There's places to draw where it doesn't touch the axis of rotation. That's going to make a disk, and so this picture doesn't show like the one above that representative rectangle as it rotates around. Here's the disk in there. But again, if we could stack a whole bunch of these washers, it would create an approximation of the volume until we get the actual volume. And so that's the idea of volumes by disks and washers. There is a video linked right here. I'm going to put that as the next video in this playlist, and definitely watch this video because it's a great explanation of what's going on. He's got a good visual, an actual 3D model that he moves around so you can see how this is all being created. Plus, he also does get you into the actual calculus of it. It's about 6.5 minutes long. It's not a long video, but watch this video, and then the next video in the playlist will take you back to my notes.